All right, today's lesson is on graphing log functions. And to help us graph a log function, it would really help to graph or look at the exponential function. This is an exponential growth because they are related, and I'll show you how they are related in a minute. But if you remember when we graphed these, we first made an XY table, and an exponential has a domain of all real numbers, but we use -2, -1, 0, 1, and 2. And if you plug those in, I like to start here. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, and these other ones are just the reciprocals. These two are related because they're reciprocals. So that's 1/2 and that's 1/4. Right, now if you graph that, there's no transformation, but if you graph that, you got your points here, and I graph that on this XY plane. I have -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. So it's an exponential growth. As x increases, y approaches infinity. As x decreases, or as x goes to -infinity, y approaches my horizontal asymptote of y equals 0. So how are these functions related? Well, let's take a look at this function here. And I'm going to replace the f of x with the y. And I'm going to find the inverse of this function. Now remember, an inverse, step one is to switch the x and y and solve for y. Now, how do you solve for y? Well, we've learned earlier that this exponential function can be written in log form by taking the base of the exponential, which is 2. The exponent always goes on the other side of the equal sign, so log base 2 of x equals y. So you see that the inverse of this exponential function is a log function, and you notice that's the same thing as this. So these two functions are inverses. And if we take a look at the graph, then we should see that they are a reflection over the line y equals x. So how do we graph this right here? Well, it's difficult to do this in this form. I could use the change of base, but it's easier. First, let's rewrite the g of x as a y, and then change this to an exponential function. So I go around the world. It'd be 2 to the y equals x. Now, for many, many years, your teachers have been teaching you pick values of x. Well, why can't we pick values of y? I can do that. I can pick -2, -1, 0, 1, and 2, and plug those in there. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. And then these are just inverses, so this is 1/2. This is 1/4. And now you notice these are just switched. The x's became the y's became the x's. That's because they are inverses. So if I graph this now, these ordered pairs, I go 1/4 of a unit to the right, I go down 2, 1/2 of a unit to the right, down 1, 1 unit to the right, don't go down or up any, 2 to the right, up 1, 4 to the right, up 2. And this is what a log graph looks like. And these are just inverses. They're a reflection across the line y equals x. That is definitely true. You can see that. So what is the domain of the original function? This exponential growth, the domain was from -infinity to infinity. And the range from bottom to top is 0 to infinity. Something interesting happens on domain and range of the log. Notice now the domain from left to right, it doesn't start until 0, and it goes on forever. And the range now goes from bottom to top forever, so that is negative infinity to infinity. And if you notice, the domain of the exponential function becomes the range of the log function, and the range of the exponential becomes the domain. So how do we do one of these now with a transformation? Well, the transformations are exactly the same as they've always been. This plus 2 means I'm going to shift the graph 2 units to the left, and the plus 1 means I'm going to shift it up 1. Now all I need to take a look at is log base 2 of x, and I'm going to replace the h of x with a y. This is just a log function, just like on the last one. So I'm going to go around the world 2 to the y equals x. I'm going to make some values here of y, negative 2, negative 1, 0, 1, and 2. It's basically the same table that I have here because it's the same base. So this is 1/4, this is 1/2, this is 1, that's 2, and that's 4. But if I put in this translation, just move the y-axis over here. We've been doing this all year, so this is not new. And then up 1. And then I'm just going to graph these ordered pairs starting at my new origin. So 1/4 to the right, down 2. 1/2 to the right, down 1, 1 to the right, down 0, 2 to the right, up 1, 4 to the right, up 2. So basically what we're doing is we're graphing the parent function, which is this one right here, after the transformation. So let's take a look at this. What is the domain? From left to right, the domain, the graph doesn't start till negative 2. It doesn't equal negative 2 because that's a vertical asymptote all the way to infinity. And the range is always on a log function, negative infinity to positive infinity. All right, let's try these two. This is the exponential function. So I'm going to graph this. Now here it's easier to put in values for x, so I'm going to put them in. Plug them in. 3 to the 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9. These are reciprocals. Right, so I'm going to graph this over here. There's no transformation, no shift right or left. So negative 2 up 1/9. Negative 1 up 1/3. 0, 1. 1, 3. The other one doesn't fit, but that's okay. I'm just going to graph towards it. This one over here is never going to cross over the x-axis. That's my horizontal asymptote. So if I rewrite this in exponential form around the world, I'm going to just replace the g of x with a y. Go around the world, so it'll be 3 to the y equals x. So my table of values, I'll plug in numbers for y. Replace those, the y's with these values. So this is 1/9, this is 1/3, this is 1, that's 3, that's 9. And I'll do this in red just to show. So 1/9 of a unit to the right, I go down 2. 1/3 of a unit to the right, I go down 1, 1, 0, 3, 1. The other number doesn't fit. That's okay. Just draw it towards it. So this one has a vertical asymptote. The growth has a horizontal asymptote. And the domain on the log from 0 to infinity, the range always the same on these, negative infinity to infinity. All right, this one is just a transformation of the parent function log base 3. The shift is right 2, down 3. So I'm going to put that in right away so I don't forget. Right 2, down 3. Now I don't have to worry about that minus 2. I don't have to worry about the minus 2 and plus 3. So let's rewrite this without the minus 2 and plus 3. And I'm going to replace the h of x with a y. So I go around the world, so it'll be 3 to the y equals x. These two equations are exactly the same. This is log form, this is exponential. So I make my table of values. Because it's a base of 3, just like the last one, I could use those same exact numbers again. I know this is 1/9, this is 1/3, this is 1, that's 3, that is 9. And I graph those starting from this new origin. So 1/9, down 2, 1/3, down 1, 1, 0, and then 3, 1. The last one doesn't fit, but that's okay. I know what's happening here. I understand. Farther it goes to the right, it goes up slowly. The domain, what's the first x? The first x is right here, but that's a vertical asymptote. So x can't equal 2, that's why we use the parentheses. For the range, always the same. Negative infinity to positive infinity. Now suppose this didn't have a number. Remember that base then is understood to be a base of 10. All right, good luck on your homework. Have a wonderful day.